Pause if necessary, but please take a moment to read the following.
Hello and welcome to the second video of the Tracer series. In this video we're going to look at the physical building of the Tracer itself and we're going to start by building the case. In the first video we decided where everything was going within the box, and so we've taken the first video into account. I've designed on Fusion 360 and 3D printed plates for the commercial box. With these boxes, they're designed so that there's a thin piece of plastic, and the idea is that you cut your holes in this piece of plastic and they slot in place, and then you can replace these with any piece of plastic that you can cut to the right size. It's basically 2mm thick, and that goes in where that one is there at the moment. So if we use a 3D printer, it's very easy to do the same, and these are the same thickness, the same height. The only issue with this particular box is the size of it, and so what I'm going to have to do is split the piece of plastic into two. So these two pieces of plastic will go into the slot, and where the join is I'm going to use some super glue with accelerator and a small piece of scrap plastic on the back where you won't see it, so that appears as one piece. The line down it is a small price to pay for the accuracy of all the holes, and so that's the plan. On the front I've done the same as that, and this will be the front of the box. As you can see, I have made a very slight change to the design while I was designing the front parts. You'll notice here where the socket for the scope is, above it there's a hole. That hole is for an LED, and what I'm doing is I'm going to replace the scope and computer switch with a double pole, double throw switch, and effectively the second half of the switch I'm going to use to simply pass the voltage required to the LED. So when it's in the position I want the light on, which will be scope, the LED will come on, and when it's connected to the computer the LED will go out. So it's just basically a telltale so that you can see at a glance whether or not it's going that way. So that covers the front and back. Now when we actually designed the circuit, we decided we're going to have gauges on top and the potentiometer and switch for adjusting those. Now what I could do is I could just cut those holes into the plastic, but the plastic box has this nice grey colour with the black contrasting panel. So what I thought was that rather than just cutting them straight into the top, I'll add a black panel just like on the front, and into that I'll accurately cut the holes for the gauges, the pot and the switch. So this will go here, and basically the idea is that you drill the 6 holes, put the nut and the bolts through it to hold it in place, then you can draw around each of these holes, remove the plate, you've got an accurate location for where the holes need to be, and then you can cut basically a hole a bit bigger around the 2 gauges so that there's room for the clips on them. And where the potentiometer goes for the grid, the actual potentiometer has 2 tabs that stick upwards to stop the potentiometer body from rotating when you turn it. So what we can do is we can drill those holes next to the potentiometer hole on the lid, and then when you place the black plastic in there, the actual shaft will go through the lid and the plastic, and you can turn the potentiometer. but the body is held in place by its holes that go into the actual plastic of the lid, which you'll never see. And then obviously the gauges themselves nicely slide into the rectangular hole, and that will create a very neat design. I'm going to be using my label printer. I've got a little Brother label printer that prints white on black. I'm going to use that for labeling it because not everyone's going to have a 3D printer, and some of the writing is quite small. 3D printers are great for the small writing if you have a multimedia unit. Doing the printing so that it actually is embossed, if it's small, the letters just get knocked off quite easily, and this is a piece of lab equipment. It's going to be moved around the bench and screwdrivers will hit it and so on. So because of that, the only place I've used that technique is for putting valve tracer on top. If you want to know how we can do that with a one colour printer, I do have a video, I think it's video 8, where I demonstrate how to do that. So take a look at that if you want. But this will give us the design for the actual box itself, and this is what I'm going to use for the separate valve cases. So I have these standard size plastic boxes. I designed this box for a standard sized panel, and basically I can design these panels as I like. I already have a design for the 3 valve sockets and the switch, as I explained in the first video, because I'm using that on my rack tracer already. So I'll print one of those out, so I'll show you both the designs, and then I have a really nice valve coming in the next few days, and it uses a socket that I haven't needed before, but I do have some of those sockets. So in this box I'm going to add a couple of sockets that I rarely use, but the idea is that with these boxes you can just connect up any valve that you like. The other thing is that in a series I'm going to be producing later on in the year, I'm going to start building up whole sections of amplifier in bits, so that you can create your own designs by literally plumbing the sections together. I'm not going to talk more about that for the moment. That's for another video, but these will be usable in that as well. So you're creating parts that you can use with various pieces of equipment. So what I'm going to do is I'm going to show you the actual 3D design work, and then once we've seen that, I'm then going to move on to the actual building it, soldering everything together, and where the leads go and the like.
What I'm doing here is designing the rear panel of the box using Fusion 360. Fusion 360 allows me to be accurate with wherever everything is going and easily create non-standard shaped holes. The fuse holders themselves don't require a round hole, they actually require a hole with 2 sectors cut off it, basically sort of like an oval sort of shape. The IEC main socket likewise isn't just a rectangle, it's a rectangle with one end as a sort of chopped off triangle, and for that reason it's far easier to measure everything and then create it accurately using 360 and then print it out. So that's what I'm going to do here. As I said in the first video, the print area of my 3D printer is actually too small to print the width of the box I've chosen. It's a Prusa i3. The print width of that is 250 millimeters, and the box is, I think, 320. So I'm actually going to print both the front and the rear panels as two single pieces, and probably glue them together with a strengthening piece on the back where you won't be able to see it. I'm showing you this at double speed because it's not the most interesting thing watching somebody else doing something like this at normal speed. If there's something you're particularly interested in, then just pause it, slow it down. If you've any questions about how I've created anything within 360, just leave a comment in the after the video, and I'll explain it a bit more. And if there's call for it, I'll actually do a video at the normal speed and explain exactly what I'm doing and how I've done it. For now, though, I'm going to leave you with this, and we'll pipe in some copyright-free music as well.
I've been keeping myself so busy, pushing out the misery, trying to find the peace in me. I wanna be pushing myself to the edge, not wanna go away. Been testing myself by the worst. I've been pushing my mind to the most. I've been loving the people around me, but I'm so paranoid, I'm so paranoid, yeah.
Right, now at the bench, you can see that I have the box with the components in roughly the same positions as they were in the original diagram on the first video. I've swapped the transformer and the PCB around for the grid power supply because the transformer was too close to the mains input that you can see here. So basically the pins on the back of here would have been too close to the transformer, so these two have been swapped around, and the lead should be long enough, but if it isn't, I'll solder longer leads on there. The first task we've got is to mark out where we're going to need the mounting holes for all of the devices, and that's a simple matter of using a marker to mark the holes. Something that I've found which is quite useful is called a carpenter's pen. This is by Edding, and basically it's got a long shaft before the fibre, and you can actually put it through much deeper holes and still make a mark. So that's something that's worth having when you're building your own devices. You can pick them up on eBay. They're only a few pounds, but basically they do make it easier. The only component here that is going to cause a problem is the power supply for the filament, which has screw holes on the bottom. For that, I'll show you how I'm going to make sure they're in the right place once I've fitted these components. So basically what I'm doing is simply marking the holes, and then I'll come back and I'll drill those in a moment. Now, when you use a drill, you could find that if you use high-speed steel ones, the tips on them have a tendency to wander unless you center tap the hole. So basically what you can do is you can put a pointed object on and give that a tap, and it creates a dent where the drill bit's not going to wander off from. There are also auto punches where you push them down on the mark and it leaves the dent. Because this is plastic, you can use wood drill bits, and what I'm using is a wood drill bit that has its own sharp point on the end. That can go exactly on the hole and it can't then wander, and you always get the hole in the right place. So I'm just going to fit the circuit board first. Okay, then I'm going to work my way around just making the holes for the transformers and for the other circuit board, and then I'm going to mount them in place. We need to do something with the main circuit board, so I'm going to mount it and then I'm going to remove the board from the mounts, because what we're going to do is we need to remove the LED and fit a header. Okay, as you can see, I've now fitted the main circuit board in place. What I've used are these, well, PCB mounts basically, with an M3 threaded brass insert on the top and bottom. So they hold the circuit board off the base of the plastic box, and from underneath I've drilled the holes, and then I've used a countersink for a drill, and what I've done is I've mounted it into a handle, That's glued in place, and I use that basically whenever I'm putting screws into plastic like this. It's a handy little tool to sort of make for your toolbox. So that goes through, and then there's a shape-proof washer, and then the mount, and then the board screws in place, and that is absolutely rock steady. I don't trust the plastic mounts that they give you, and they're very rarely in the right place anyway. I prefer a proper machined thread in order to hold things in place, especially when we're looking at voltages in 3 digits. I don't want that rattling about inside. So I'm now going to carry on and mount the transformers and the upper board. Okay, so we've now got to the point where the transformers are all fitted and the circuit board for the grid power supply. The posts are in place for the main circuit board, and they all line up properly, and the only thing left now is the filament heater box and the USB. We'll leave the USB for now. Getting these lined up, the easiest way I find is to stick a couple of the right size screws into the holes, and then if you measure the distance between them, which in this case is 60.7 millimeters, and then take off the distance, the thickness of one, so 60.73, and this is an M3, so 60.73, 57.73, so basically 58 mil should get us holes that are the right distance apart. So what I'm going to do is, this doesn't need to be absolutely exact, so I'm going to mark where I want my first hole, and then 58 mil away from that. Not ideal using these as for measuring distances like this, but it'll do for this. Okay, they should now line up, and the hole should be in the right place to screw in from the back. Okay, now one thing with these is you need to make sure that the screws that go in aren't going to go right through and cause damage inside. So we need to know how far in we can actually go and how thick the plastic is. So what I'm going to do is I'm going to countersink my hole. Stick it through. That distance, that's too long, that screw. So I'm just going to find a screw of the right length and fit that. Okay, and this hole should line up, which it does perfectly. Okay, so as it stands now, we have everything in the right place, and we can start looking at the front and back plates.
This seems like a good place to stop. I'm still filming the build, but the video will be too long in one piece. I already have another 20 minutes of footage and will add to that over the weekend. The next video will be in a few days, then the final build video next week. Then we can start using it. So please like and subscribe, and then you won't miss the next video. Thanks a lot.